We've talked about titration, and that's when moles of acid equal moles of base. And because we're perfectly neutralized, we can use that MV equals MV formula divided by the coefficients. Today, we are not going to go to perfect neutralization, which means I'm going to have an excess of the acid or an excess of the base. Now, my acid and base are the reactants, and that means if I have an excess of one of them, I'm going to have a limiting excess reactant problem. The first thing we have to do is, because we're in solution and stoichiometry is all based on moles, I have to remember how to convert a solution to moles, okay? So molarity equals moles divided by liters. So molarity, let's just put a little arrow there, molarity times liters equals moles. Remember, N is moles, okay? So here's my problem. I have this much sodium hydroxide and I'm combining it with iron nitrate, and here is my reaction, and I'm going to make these guys, and we're going to form a precipitate, and we need to figure out how much precipitate is formed. Since this is a limiting reactant problem, I need to figure out moles and moles and determine which one's a limiting reactant. The easiest way to do this is a BCA chart, because of all the other questions they're going to ask, we're going to need this information. So 3 moles of sodium hydroxide react with 1 mole of iron nitrate, and that is going to make 3 moles of sodium nitrate, right? Switch the partners, and a mole of iron hydroxide. Now, I like to use these coefficients to make sense of things. For every 1 mole of iron nitrate, I need 3 times that mole of sodium hydroxide. So I like to put my 1x's and my 3x's there to remind me of what's going on. Okay? So the first thing I have to do is find my moles of sodium hydroxide. So moles of NaOH, moles, is going to equal my liters. Now I have 100 milliliters divided by 1,000, moves it over 3. So I have 0.1 liters times 0.35 molar solution, which is going to give me 0.035 moles of sodium hydroxide. Okay? And now I need to find my moles of iron nitrate, FeNO3, and that is going to equal, I have 400 milliliters, which is 0.4 liters, times 0.025. Now I'm not using all the zeros after there. There are 1, 2, 3, 4 sig figs, but that makes my writing messy. So remember, this is 0.4000, okay? And that is going to equal, if I put it in my calculator, 0.01 moles of iron nitrate. So I can put this in right here, 0.01 moles, and this is 0.035. So now I have to find which one's gonna run out. So I always like to pick my lowest one. Why? Because this is 3 times more, right? If I did it with stoichiometry, I'm gonna make a little excerpt here. I have FeNO3, okay? And I have 0.01 of that. I don't want FeNO3 anymore. I want NaOH, and that's a 3-to-1 ratio. So what does that mean? That means I need 0.03 sodium hydroxide, okay? Why? That's just 3 times as much. Okay, divide by where you are, multiply by where you're going, and how much of this do I need to react with that? I need 0.03. Do I have 0.03? I do. Do I have excess? I do. So that's excess, and this is my limiting reactant. So now this is the number I use to find all of these guys, okay? So this is my limiting reactant, so I'm going to use up 0.01. Now, 0.01, and I'm not going to use my things here, but 0.01, get rid of that and go to this. I'm going to use minus 0.03, okay? Now, notice if this is 3 and that is 3, this number has to be the same as how much I'm using up. And you can do that. It's a 3 to 1 molar ratio, and this is a 3 to 1 molar ratio. So I'm going to use I'm going to make 0.03 of that. And this is a 1 to 1. So if I use 0.01, I'm going to make 0.01. Now I'm just using the mole ratio from my balanced equation, and you need to pull out your mole island if you need a refresher on that. Okay, so how much do I have left? I have 0.005 left. I have nothing left, and I made 0.03 and I made 0.01. 0.01 what? Let's remember that our BCA charts are moles only. So this is moles, this is moles, this is moles, and this is moles. So when I'm calculating this percent yield down here, I need to determine grams. So I need to convert my grams. Now it says I have precipitate isolated. My precipitate is FeOH3, so my theoretical yield needs to be determined from this, okay? And I have 0.01 moles of FeOH3, okay? And I don't want moles, I want grams. For every 1 mole, it gave us iron hydroxide, or I could add up 1 iron, 3 O's and 3 H's, and I would get 106.84, okay? So when I multiply that all together, that gives me 1.0, and we're going to round that to 7 grams of iron hydroxide.
Good afternoon, Myron.
So what I've calculated here is what should happen, and this is my theoretical. If I calculated it, it didn't really happen. So it says I have 0.75 grams of this precipitate isolated. That means that's what I got in the lab. And our percent yield is actual over theoretical times 100. So my actual is 0.75 grams. And I'm going to divide that by 1.07 grams. And that's going to give me roughly, that gives me a 70% yield. Not so great. Now, what is my excess reactant? That is NaOH, should be a little a. And is the resulting solution acidic or basic? Well, if I have an OH in it, it's a base. So my solution is going to be basic. So we need to find the molar concentration of the excess reactants, okay? So remember, liters is total liters of solution after they're mixed. So moles is moles divided by liters, and my total liters is 0.1 plus 0.4. So my total liters of solution is 0.5. And you divide this out, you get a molarity, or a concentration of sodium hydroxide as being 0.01 molar NaOH. And this is that excess in our solution that's making it a basic solution. So now what we are going to do, we're going to calculate the OH concentration. And so sodium hydroxide breaks down into sodium plus OH minus. That's a 1 to 1 to 1. So if this is 0.01 molar, this is 0.01 molar, and this is 0.01 molar. Okay, so it is 0.01 molar solution. Now I like to write this when we're doing our pHs and everything is 1 times 10 to the negative second molar solution. And now that makes it very easy to see this is 1 times 10 to the negative 12th molar solution, because these two multiplied together have to equal 1 times 10 to the negative 14th. And it also makes it easy for me to make my pH, which is 12. Okay, you could put it in your calculator, or you can remember pH is the power of our H's, and if this is 1, I can just go right off of that. So that's how we're going to do these problems.